It's the Dev Friday Show with Mark and Tim.
It is the Dev Friday Show. It is with Mark and Tim, and we are just as prepared as we always are, which is to say, not all that prepared. You know what I actually did? I listened to the last part of last show because I realized that sometimes we talk about doing things in the next week, and maybe I should know what we're going to talk about doing, and not just completely forget it like I apparently did last time when you told me you were going to interview me about API stuff, and I did not remember. So I listened, and if we're going to come with a topic, I don't know, crazy idea. Maybe we should talk about that just briefly, so I can make the title match the topic.
That's true.
So I don't know.
Instead of me just like logging on like 5 minutes before the start of the show, and then we're like, all right, can we hear each other? That's
pretty much it. Yeah, as long as we got that working for us. So, last week, what did we ended last week. I don't know if we want to go into it. Yeah, but we ended that last week talking about, I guess you're doing more stuff with PyGamer.
Yeah,
balls bouncing around the screen and all that kind of stuff.
Yeah, we're starting to do we're in my object-oriented programming class. I'm using a PyGame which is a Python kind of, some would consider a game engine, some would just consider a Python package or set of libraries that enable you to make games with Python.
Wait, some would consider it a game engine. What is the threshold there that needs to be met for it to be a game engine per se?
It is. Maybe I'm not the best one to provide a definition, but if I think about a game engine, I think about something like Unity, Unreal, Godot, which is kind of, it's all integrated. It basically is like its own IDE, its own interface application. Then you can basically create your game with inside of the application, and then it runs it. So it's not just a set of libraries that you can then import into your Python files to then run. But like I said, if you code it, I would still consider it a game engine in a sense, because you are using those libraries to generate a game. I guess that's what So it's in order to provide your game loop and your and the drawing the objects to the screen and the detecting collisions, interactions. It does provide that functionality too, which a game engine would. But like I said, I more consider it like a set of libraries. And it also is not meant to be a professional game engine that you would make, let's say, an iOS or game for your PlayStation. It's not really meant to be used for that. But it's a very useful library for learning Python, for learning just basics of game development. And in this course, which I'm teaching, which is object-oriented programming, learning it from an object-oriented perspective, which, using games as a way to, or even just animation or games, and to teach the students, these basic object-oriented concepts, and to have them create, interactive experiences, animations, or games. The course, I think it's actually been pretty cool experiences. What I'm doing with the students from last week, I'm starting to show them how to build asteroids. Remember that game?
Yeah. Where Now, okay, there's different variations. I feel like I've seen a version that's more like an endless scroller, where you move a little triangle type ship left and right and shoot things that are coming down to you. But that's more Space Invaders, honestly.
Well, so I'm thinking like the pure, because I even showed them the video. Because I was curious, if they remember ever seeing this, like it was pure black and white, just lines. You draw
right, and then just the little tiny triangle, and you would fly around, right? And you would fly around.
So would
you cross through the bounds and go left to right? And
that's correct. You would go off the screen, and then you would reappear again on the other side of the screen.
And you'd shoot at the asteroid and then make it smaller, and then it becomes smaller and smaller until you finally got rid of all the pieces, and then another asteroid would come through or something like that. Yeah.
Yep.
So you're working on making that.
Well, that's because I made the game. I can't remember what it was for. I think it might have been for like a grad school assignment or something like that. I made it in ActionScript many years ago. I made a version of that, and it was actually a pretty cool experience. It was my first time making a game, like a top-down shooter game with a spaceship flying around, and so I did that in Flash, ActionScript 3, I believe. So It was kind of a fun experience. I thought, actually, this would actually, I was thinking about what I had to accomplish to make that style of game. Having starting with the rocks, getting them to float around. Once they got them to float around, they place the player's ship, and then be able to have like some type of a force with the ship, so that when you pressed on the arrow keys, it'll then start to generate force to push the ship, but then also have some momentum, so the ship won't, it won't stop at a dime. It'll just kind of slowly
Because
so
that
that's
game,
also
you never stopped. Yeah. There was no real. I mean, I guess it was real slow deceleration.
But it feels like
if you went, you just fly through the screen. There'd be no way to stop yourself.
Yeah, it feels like you're sliding around in ice, right? It's just kind of like you're driving a car trying to like navigate it on like a sheet of ice. So that's what it kind of feels like. So this week I got them started with that just by showing them how to draw an image on the screen, basically for an asteroid. So I got a sprite image of an asteroid, and just show them how to get it on the screen.
All right. Now I want to walk this back because I want to understand this. Mm-hmm. So you said it's a sprite image. So this is
a sprite.
An actual like a not you're not doing math drawing, like calculate line coordinates. You're actually saying this is a image of an asteroid that we're just going to put on the screen.
So it's a PNG file, yes, a bitmapped image.
Okay.
That is, and I use the word sprite because I'm talking to students about how, like, when you have an image that you want to load in and then draw on the screen within a rectangular window, or, it's considered a sprite. And so you have sprite sheets, which could be a combination of sprite images that then you kind of, pick out of the sheet. And
right. I remember looking at game design years ago. Yeah. You put them all in one big bitmap. And then you kind of load parts of it so you could have it. I'm guessing that was done for efficiency. Yeah. So you could have it all loaded in memory and easily call the region you needed.
Yeah, which I'm still going to do, but I just showed like it's okay. We have this one image of this asteroid. How can we load this image in, get it like initially to get displayed to the center of the screen, and then start to add some, speed,
float, right?
Some speed or some to get to it, and also talk about how, like, when it gets to the end, the bounds of the window, to detect that in order to then, so the asteroid could also reappear from the other side. So we talked about bounds within the window. So first,
does the asteroid do that too? I had forgotten about that.
Yeah, so I showed first, like, having the asteroid just bounce around, which, a lot of bouncing ball examples have, like, you get a ball moving around, you bounce around the sides of the screen.
Code.
Yeah, so I showed him that first. That's an easy way to do. Just detect if it gets to the sides of the window, then be able to have basically reverse the direction. But then to kind of take the next step further, okay, if it gets to the end of the window, it actually goes off the window, looking at, let's say, the width and height of the object, and that passes by the bounds of the window. Then, detect that and then make it reappear from the other side.
So and you're doing all this in Pygame, Merc?
Yeah.
Pygame, which is, you're describing it more of a library of methods to use to build games. So
because
you're make it easy to do image manipulation.
Yeah, because and the only parts I'm using now is just, you're writing your own Python files, running your own Python classes, but then you're importing Pygame, and then you're accessing, with the Pygame object that you get from when you import it, you're accessing the method. So if I went to initialize Pygame, so then I could be able to access the Pygame to object to then start drawing elements to the screen.
Does it give you like a screen notion? Like, hey, this is a something by something, in terms
of you specify screen. That. So when you draw out, you specify the window, you specify this is the width and height. And I also shown too how to automatically detect a width and height based on an image. So once you load the image in, look at the width and height of the image, and then use that information instead of hard coding the information into it. Use actually the information of the image. So if the image is large, and if you can also scale it down if you want to by putting a scale operation.
Kind of like your frame, like whatever your screen frame is. Okay, okay. So make the game fit that kind of Chrome that you're going to play in. Okay. This is So then from Python, when you say the image floats, so you've got your asteroid floating around the screen. It goes outside the bounds of one screen. Does it give you it doesn't give you like an overflow into the other side thing. You're actually then saying take another image and float it in.
Well, now I'm saying basically move the X and Y position of that image to the other side. So basically just, based on the bounds of the window, and if we can detect, if it goes all the way over to the right side, and if you want to kind of change the direction to start from the left side, just basically take the bounds of the window minus the width of the object, and just change the X position.
But if you're floating an image around the sprite, right? And as it starts, because the whole image isn't going to go off to the left, it's going to partially go off to the left, right?
Yep.
Do you have to create another image to bring it into the right? Because if I'm remembering the game, doesn't it kind of, as you go out one side, you immediately come in the other side? It's not like you clear the screen first.
Oh, that's a good point.
Don't you have to have two images that you kind of like shift
That's correct. If I just did a point where if it floats all the way off, so it basically removes it and then just change the position of it. But I get what you're saying. If you want to make a clean transition, so you actually see it reappear automatically from it, then you may have to redraw another image.
That's how your spaceship is going to operate, right? Your spaceship's always going to go up the top. You go off the top and then come back immediately through the bottom.
Yeah.
And I'm trying to remember that the original game, and I feel like as the nose of your spaceship would go off the top, you would see it at the bottom. It was one of those like infinite, I don't know what you want to call it, but you couldn't get out of that box ever. You never actually left anything. You were always taking up the same amount of space.
So getting back to the object oriented, what we went over this week is having an asteroid class and then defining some properties about the asteroid. So basically the image or the sprite that the asteroid is going to hold. So that could be different image, could be have a different image size. So the scale of each asteroid could be different, showing how we can encapsulate the data or the properties of each asteroid and make it unique, so that if you want to randomly generate asteroids, because that's also where I got to at the end,
a bunch of different images of asteroids.
Yeah, if I want to like load in, let's say 5 or 10 different asteroids when the game starts up again, you could randomize the properties in a sense, like the scale and size and speed, and so you can they'll look a little bit different. Maybe also the rotation, because I also talked about how to like rotate the image, which is a little bit tricky in Python because how it uses like a top left coordinate system. Which so when you're moving an object around, which a lot of game engines do too, it basically gives you like a frame or a rectangle, and the coordinates of like that X and Y position is based on the top left of that frame.
Right. So
if you rotate around that, it can cause some weird issues where the image just won't look like it's rotating around like a center axis. So I think and it also deforms the image a little bit. So you have to, when you do the rotation, you also have to swap out the image object, and it's a little bit tricky. It's not a clean process in Pygame.
Feels like exactly why you want an asteroid class to wrap this, so you can have a nice little method that says rotate and maybe what your rotational velocity would be. And then it'll take care of all the crazy stuff that you have to do to make it work on the screen.
It's talked about how to do like a draw method, so it draws the screen, how to do an update method, so you can basically update its properties, or like say each frame that's being rendered, what's happening to the asteroid.
How are you doing timing? I know this is outside of the asteroid class. I'm guessing the asteroid class also has things like the XY coordinates, and you say it's from the top left. But do you normalize that for the purpose of the asteroid and do it like from the actual center?
When I do the rotation, yes, because if you don't rotate it from the center, it just looks off and the image looks distorted and it doesn't have a clean rotation. So when you do the rotation, you have to specify where the center is. You basically have to take the image, specify the center for that, and then do the rotation for this. So there's a couple extra steps, and also how Pygame treats like a rotation compared to a scale. It's weird how you have to like basically instantiate another variable of that image that you're actually going to rotate within the frame that's being moved around the screen. So it's a weird process, but it was actually kind of interesting to kind of show them, just one of those workarounds to do it. It is what it is.
You can call rotate. No, but I was wondering, you could even take your asteroid class and you could say, Pygame always links the coordinates from the top left, right?
Yeah.
But you could say, but our asteroid class is not going to do that. Our asteroid class is actually going to represent its position by the center, because it can do the math to say so you can say, put it here, center of the screen, and boom, it's centered. Yeah,
because even though it moves it by the top left, you still have access to left. You can still, if I want to get the coordinates from like the center, left, right, bottom, top, you can still, there's points around that frame.
To your consuming code. So your consuming code is just pushing an asteroid around from the center coordinates. Now, though, I'm curious, how do you do the game clock?
So it's interesting. They have this clock option. So we basically load it in. There is not.
Pygamer would have it, right? That makes sense. Yeah.
Well, that's usually what game engines do to kind of manage like the frames per second.
Right, because I don't do this type of stuff. So this is fascinating to me.
Well, in other game engines, when I did last year, when I was taught with Godot, they have, and also with other game engines like Unity. If I want to move elements around to kind of have some because when the game engine is rendering your game at like 60 frames or 30 frames per second or whatever, usually defaulting to 60 and trying to do that consistently. If you're moving objects around, let's say changing the X and Y position, you don't want to change it. Like you might not want to add 1 to X every millisecond or every kind of frame, because it's going to be rendering that 60
frames per second. So you've got a 60th of a second.
So in other game engines, they have this concept of like a delta. So basically it has this delta function where you could basically reference the delta, and then the game engine manages how many frames have been rendered over that second. And then it'll basically put a little bit of delay when you increment like the X and Y position in order to move something across the screen. So it's not like just jumping or moving super fast.
Oh, so you give it what your frame rate is, almost like the speed
the game engine handles
animation to do.
You can specify in like the game properties what your frames per second you want it to be, but usually it defaults to 60 frames. It tries to render 60 frames consistently, but then it uses this delta function so that when you're doing some calculation, like accelerating something or moving something across the screen just by changing the X and Y with some speed variable, you would then times it by this delta to then basically give you a number that's based on the time, how many frames are being rendered.
Right.
So it'll look more natural as you're increasing, you're moving objects across the screen. So that's the way other game engines.
That's the turbo button of the game of the game engine.
So the way Pygame handles this.
Wait, you remember the turbo button, right?
Oh yeah.
It's like the turbo button. You're just like, oh, this is going to go way too fast. Let's just increase the delta here. So
with the way the Pygame treats, and like I said, I'm still new to Pygame, even though I'm teaching this special, but that's what we do as teachers, right? We're learning as we go here. Even though I've done Python a lot before, but they're using Pygame's first semester to using it. But they have this idea of a clock where you could specify a clock, and then you could tick the clock, and then you give it basically a number like a frames per second. And so within your game loop, let's say at the end of your game loop, you specify this clock object based and sending it as an argument the frames per second that you want the clock to go at, and it'll basically put a little bit delay there within the game loop. So
gotcha. So there's just there's a game loop, and that's constant time then.
Yeah, that's rendering. Yeah, that's right. Every time if it's 60 frames per second that's being rendered on the screen, it's rendering 60 times per second, right? So every time something's being drawn to the screen, you're doing operations within the loop, and then you can slow that loop down based on the frames per second that you want to go to. So what will happen? It'll just try to do as fast as possible,
right,
with it until you actually put this clock in here to slow it down to what your frames per second is.
Right. So the clock for Pygame gives you what is essentially, I'm guessing, just a
delay,
a main loop, though, right?
Yeah, well, so you have this, like you could do like with a while true. So basically, when you run your main Py or whatever file that is basically instantiating your classes and generating,
there's a method that's going to be called every time. It's basically what should I do every frame, essentially. What happens if you throw a sleep in there?
So like
will it actually make your game laggy?
I haven't tried. I think that's kind of what the idea of what the clock is. So you could basically kind of put you can use that object to basically to pause in a sense to stop it.
Right. Does your loop like emit it? Is that how you do it? You like do your stuff and then say now, basically yield to the clock and say, do the thing. Is that what the clock is doing for you? Is essentially
no. It's basically just in the main loop, and all it does basically just gives you like a delay. It kind of just controls like how fast that loop is running in a sense.
And then if you take more time than what it would delay, you're just going to slow down your frame rate.
Yeah.
And you're going to be like, why is this game laggy? As you start to do some crazy math.
Or if you start loading in like 20 images or 30 images that are really big, and then you'll start to see it. Because the student asked me this, like he was following along, and then he said like, oh, I changed the number of asteroids that were generated on the screen to like 20 or 30, and it really started to like slow down. So is there like some performance issues with Pygame? I was like, yes, Pygame's not meant to be
some performance issues with Pygame.
The best performing game engine that you would use for your professional game, but you just have to kind of work within its limitations. But
now I want to go two different directions there. One, I want to come back to talking about like putting this on a hardware device. I want to go back to that because I know it's possible, and I'm super intrigued by it. But like that loading thing, so that's why one would assume, if you have the memory capacity and whatever hardware you're running in this, you'd say let's load the image into memory before the game even starts, right?
Yeah.
Because you don't want to be like, oh, time for new asteroid. Let me go fetch a file and load it in, because your program right now is saying I need to every second, every frame, basically be saying what animation should happen. So
correct.
That's why when you boot up the game, you'd have like a loading screen, right?
True. Yeah, it's loading that all into memory, and that's something I do. We're definitely gonna talk to later in the semester as we kind of get farther along to talk about some memory management. If you instantiate some objects and let's say if you have some asteroids and you blow them up and they're completely off the screen, are they still going to be in memory? Right, and kind of making sure you can. Depends.
Right, like are you going to reuse it? Like you say, if it's a sprite that you have a page or what'd you call that? What was it when you have a bunch of sprites on a
sprite sheet?
Image? Okay, so if it's a sprite sheet, then maybe the whole thing still stays in memory because you've done that on purpose, because these are all the assets you're going to use in your game. The object itself, well, how much memory does the object take?
Yeah.
And
which that's what I want to do.
Is Python at garbage collection? I don't remember.
It's interesting too. I really, because it's meant to be a dynamic language, runtime language that's meant to kind of handle that for you. And I really, from just writing just normal like web apps or server side apps with Python, I didn't really have to worry about that too much. But it's interesting when you're working with these graphic libraries and trying to deal with objects that need to be, these graphic objects need to be stored in memory, and then how you probably need to kind of manage that a little bit. So it does have some like a destroy method. You can definitely
you can say, I want this object garbage collected.
You can force it. Yeah.
Gotcha. The loading thing reminds me of a story I heard about EA Sports. I think it was FIFA. Is it FIFA? It took so long to load because everything they were doing, which is, when you think about it, exactly what we're talking about now. Let's get everything into memory in a place where we can actually play this game and render it in real time. So that process of giving everything from disk into memory and ready to go took so long to load, it was a huge frustration to players.
Yeah. That's always been like, if your games are stored on like floppy disks or DVDs or like Blu-rays or whatever the format is, just reading it off a physical disc is always so laborious for the computer to do. That's what is the biggest issue. Like think about your gaming computer, like the biggest thing you do to speed up the performance is you get an SSD or an M2
or encrypt your hard drive.
I wouldn't recommend that.
But the solution that they had was, all right, we're like, you would think the normal solution was like, how do we make it load faster? But instead of that, they're like, we're not going to get it to make it load faster because we have to do all this stuff. What if we carve out a little bit of the capacity of whatever platform we're on and allow people to play a little mini game, and we'll call it a skill boosting game? So FIFA in the load would give you like this quick, practice your skills little thing, and the whole point of it was to make you not get so frustrated that it took forever to load the game. So instead of optimizing it in a way that I don't think they thought, well, we really can't. This is a constraint. We have to do it. We have to load all this stuff. It takes this long. But what if while that's happening in the background, we take a real simple thing and just let you work on your pass or work on, whatever it was. So they introduced these skill building things that were there just to keep you busy while they did the long work of getting everything into memory so they could launch the game.
My favorite thing was seeing how game designers would use elevators to do that too.
Like in like a first-person shooter or something,
like in a building, or I've seen this in spaceships where like it has to if you're going to go to a different level of like a physical level within that building or within the ship, you go into an elevator. There's a cool little animation. You can move your character around inside the elevator. You can look around. Maybe you can even talk to another character and have a basic conversation. But maybe the whole purpose of that elevator and why it lasts so long
was to get you to the other floor, really.
Basically to load, physically load that scene into memory. So it just took a bit. So those creative ways for dealing with constraints. And now your students are trying to deal with the constraint of loading too many asteroids. I don't know if it was an ostrich or an asterisk that was trying to come out there, and trying to figure out how to make that work. Well, so physical. Put it in put it on a physical device. I know there are plenty of Raspberry Pi, even I think the new microcontroller. And Adafruit has a bunch of like ready to go handheld, has a Raspberry Pi on it, has a screen. I don't even know if you have to solder it together. I think it just clips together. So it's like a Game Boy style, like classic Game Boy,
like just a little handheld, like whether it's whether it's Game Boy or a controller, yeah.
The screen has a little digital pad, a couple of buttons on it.
Yep, like a 4-button up, down, left, right. I think there's one that might have a stick, and I ran into it because there's that scratch-like thing that Microsoft has called Microsoft Make Arcade, and you can build your game with that and then compile it essentially, so it'll run on these hardware devices. But you could also just write it in Pygame and do that. That's what they're doing underneath the hood. That's what Microsoft Make Arcade is doing, I believe. So you could just write the Pygame and then have it launch automatically on start, and it'll run right there. So that might be a fun thing as kind of like the end of your, the end goal if your students are trying to make this game is to say, well, let's see it run on a real thing, and then put it in people's hands, and then I don't know if you can
it could
get
be
people that aren't in the class.
I can get the actual how much these devices cost.
They're not much, and you could just flash it with. I bet depending on, I don't remember what was on the device in terms of hardware,
Mm-hmm.
but my gut says you could probably build a game loader and put everybody's game on one, and they could just pass it around. But I think they were like $30 maybe, something like
Okay.
that. They're not a huge investment, because all it is a very focused Raspberry Pi. Or it may not even be the Pi. It may be like more of an Arduino style thing. I don't quite remember whether it's a microcontroller or an actual computer.
Yeah, so I'm looking at the Adafruit one, and it has with Adafruit Pi Gamer. Yeah, it looks just
Yep.
like a Nintendo DS
Yeah.
style, with with you have like an analog stick on the left, and you have
Yep.
I don't know if it has a D-pad. I don't think it has D-pad, but it does have an A and B button. Yeah,
Oh,
that's
right,
cool.
right. Yep. Yeah, and I have a couple different variants of that here that my second oldest was playing with to put her games onto. 3 printed the enclosure, didn't quite put it together yet, so I wanted to get the enclosure put together so she could just carry it around. But that may be a nice way to kind of say, oh, you've made a game, and now, like, don't just play it on your keyboard, but this is what it would be like to be in somebody's hands, because that's a different step,
Yeah.
going from, okay, I can see it running on a computer, but it's not like a game that you would normally run on a computer. It's Asteroids. Where would you normally play Asteroids? Well, you'd play it in your hand, right? And then to put it in their hand and be like, yeah, you could do that. You could make something for this. Is really kind of a cool.
Well, that's what I always loved
step.
about my mobile development course.
Right.
If I could get, when I was teaching that in person, actually, I'm teaching that again this spring, but we're gonna have to do it remote, based on my schedule. But when I love teaching that in class, because having them to be able to run their simple applications on their phone, and trying not just on a simulator. That's really what you could see that connection to be made. Once they could create something, get it pushed on their device and control it with their hands, and see that experience, that really kind of clicked in then.
Yeah. No, that's always fun to kind of see it come together. So
is it time?
Liking it? Are they?
Yeah, I think they were very skeptical about Python in the beginning, which I find fascinating, because I don't want to keep harping the fact of like, why am I using Python in this object-oriented course when there's so many other probably better languages to use for an object-oriented programming course. But with that choice being made out of my, it was not out of my hands, then they were very skeptical coming to the course, because they never used Python at all. So finally, by what we're in week 6 now, 5 or 6 of the course, they finally, I hear less questions about the Python syntax. I think that's finally clicked in. And also reviewing their assignments and seeing the code that they're writing, I think they're not struggling with like the lack of curly braces and the need for white space. I only had a couple students where I saw like their syntax, they're drawing some syntax errors based on like the indenting was just off, and had some issues with that. But they seem, from a language perspective, syntax, they seem to kind of click in, so that's good.
So you said 6 weeks in. How many weeks total is this thing?
14, 15.
Okay, so that if you're already starting to throw asteroids on the screen and move them around, in 6 weeks in, that's not bad.
I think, and that's what I think. Pi Game is really interesting. Like it's totally manual. Everything you have to write from code. There's no IDE. There's no interface for this at all. But the methods that you can use does a lot of work. That if you had to write these methods yourself to, let's say, for doing the interactions or handling image processing, and would take a good amount of work. So I think getting, just with a few lines of code with the library, students could start to do some interesting things. So I'm kind of liking that.
Yeah, and it feels like better than using maybe a game, like you said, like a game engine, because it's just providing you the tools, and you still really have to do the work to say, oh, this is going to be an object that wraps around this sprite, this actual object on the screen, instead of that already being done for you and just being like, oh yeah, create a sprite object and then animate. Like, no, how am I going to animate it? Well, there's not just a animation library. I actually have to manipulate the image, and there's some lower level library that lets me do that, but I actually have to write the code, like you said, to wrangle that. We have to do it around the center and rotate and all that kind of fun stuff. So that's pretty cool. Are you going to open source the asteroid game that you end up building in the end?
I probably will. It's on, well, I don't know. Right now, I'm just storing it to my private GitHub repository I use for all my courses. I basically have like a mono repo for all my courses. So
your students there, right?
So I'll have to, I have to think about that. But well, it's just I'm using this as an example to kind of show them concepts and show them ways to program it. But then I don't want them to copy paste what I'm doing. So what their assignment for this week, after I showed them how to basically move asteroids across the screen, is to create a fish tank animation. So I gave them like a fish tank background and then some different fish images. And so they have to, instead of making asteroids, they're making fish and making fish swim across the screen.
Oh, cool. Like a screensaver type of a thing.
Yeah, exactly. Yeah. I made me think about that. The old Windows kind of fish screensaver that.
What was that? Was that After Dark? Was that the big
the
screensaver library from like Windows 3 and
I think it wasn't 95.
It was 95?
I think it might have been a little bit later than Windows 3.1.
Back when you needed a screensaver.
Yeah, 3.1 we just had the star field and we had like the geometric kind of shapes kind of moving across the screen. So
that was some of the first code I ever wrote. In Visual Basic was code to do bouncy lines. Take it across, hit a wall, then come back, and that kind of drawing math, and then drawing 3 of them, and then removing the last one, so you had a little bit of a trail, and all that kind of fun stuff.
Like creating simple animations like that. That's what got me into programming was actually screensavers.
Oh yeah.
Which is like just the idea about it, because they would always pop up. They would look cool, and they were like, "Oh, how is that made?" So you look at some code examples of how the screensavers are made. I was using the day because I was starting to prep for go to college. I learned Turbo Pascal because that's what they were using at college. So in high school, I picked that up, even though I probably should have been doing
buttons for right.
Yeah, I should have probably been just doing Basic or Visual Basic or something like that. But along with also, I was doing JavaScript too in high school too. HTML and JavaScript, really early versions of it. Yeah,
I was gonna say that's.
Well, I talked about how like one of my first web pages was that actually got a good number of hits, and I got people emailing me. It was a
that's right. You were on a
like
bulletin board, right?
Soundboard. No, a soundboard.
A soundboard, right, on like some bulletin boards.
So back in the day when you could pay like $10 a month for hosting from a shared host, they didn't really care. They didn't really check too much your sizes or how much files you were taking up, even though they gave you a max of like, oh, you only get 100 megabytes for this hosting account. What I do is I loaded this hosting account with like all these sound files. Because I could download all these WAV files, and I think it was mostly WAV files, but it might have been before MP3s. So all these WAV files of like all the shows, like TV shows, movies, and I had them arranged in a nice kind of grid interface that they could go there. They could just have like pressing the buttons and then play like the audio files. So I'd have people email saying, "Oh, I love this page. Like I was looking for that sound," and like people could download the sound, and it was super fun.
So just open up your web page and use it as a virtual soundboard.
That was like one of my first web pages I made. I actually had people come to it and see. That was back in high school.
If we had more polish to the show, I would have my Elgato Stream Deck with some buttons that I could do the various bumpers for our different segments and stuff like that.
But getting back to like the screensavers, yeah, because I loved watching the screensaver always pop up, and I didn't know enough to make a game, but it's like, oh, I can make an animation, right? That's what you're talking about. You just draw some shapes on the screen, have them move around, see how the interactions can occur and how you can program that. And that was one of the first, even when my college exercises, that's what the first things I love to do is just go in there and start making some like animations.
For me, the first like thing that I played with and changed was what was it, Nibbles and Gorilla from the QBasic on the old whatever they were 8086s, and just changing the values to change how it worked, how long the tail and the snake was, and all that kind of stuff. Which those were some pretty amazing games when you think about it, that were written in BASIC. Which at that point, I don't know, BASIC didn't have methods, I don't think. It was all go-tos.
Yeah, I remember playing that game with the TSR 80.
Yeah.
TRS 80. It was like one of those back green, black type style CRT monitor all integrated into one. It was like super early on with like the floppy disk to the side of it. Yeah, it was one of the first ones, like because at the school they had one of those, and so that was kind of fun to play with and tinker with.
And everything you drew to the screen was basically a character.
Yeah.
Right. You were using blocks to build everything in different color blocks, and yep.
Good times.
Yeah. Back in the day, right?
I know kids today, they're just spoiled. They have too much technology, Tim.
Well, I mean,
too much.
No, it's just the what do I want to say? The where we can start from is different now, right? So you can have the 12-year-old who creates the mobile app because, well, mobile apps weren't even a thing. You know,
Yeah.
I was a developer before there were smartphones. Okay, so like, just the platforms are completely different. The accessibility of the platforms are completely different, and there's a whole lot more opportunity that we have now, at least in this industry, than we did before. And that's
Yeah.
just because the industry's not been around for that long. That's the truth. You know, when you said you're doing JavaScript back in high school, yeah, that's when it was first out.
Yeah.
You know, everything was new. I remember what was the first, was it Spry Mosaic? Was that the browser, like one of the first browsers ever built?
I did just when on Mozilla's, or back before when it was, what was the company that I think it was Mozilla, right? They made the first one, or was the company that made, what's the name of the browser that?
You're talking about Netscape?
Netscape. Yeah, so it was Mozilla. Netscape evolved into Mozilla. I'm getting confused in my head.
I don't remember how that worked. Maybe.
There was a browser that was before Netscape that I think I used, and then immediately just jumped on Netscape. So I was on that for a while. That was pretty much my primary browser through.
Back in when the browser didn't do much. like there was, it was HTML that was it, and we just rendered out pages.
But even think about like how JavaScript, because that once JavaScript, which came out of Netscape,
right?
Once developers are able to use it, I remember I had an internship when I was in college, probably about my second year in college, for working for a publisher, and they had a simple website. And they wanted to do a shopping cart interface. At the time, I didn't know much from a server side perspective how to do it, but I knew JavaScript from the so I was able to make like a shopping cart style JavaScript application for them that then would basically just collect the order information and then would just kind of
submit a form.
Submit a form. That's basically all that it did.
So
but it was
client side. Yeah,
it was all client side, but it basically it just generated like a post to a script that would then basically email the order to somebody. I think that's what was kind of the result of it. But just the interactions you could do even back then with JavaScript was pretty cool. And think about where JavaScript is today. How it's the language that rules all, right?
Something like that, yeah. At least on every every platform.
So I was thinking about something this week because this is what I do during the week. I think about things.
Okay.
I did get back on Twitter too this week, which I probably should have done that. Last night I started to get a little crazy on there, especially when I start watching the news too much. I'm like, oh my gosh, the world's falling apart. But but I saw a tweet from John from PHP Architect.
Okay.
John, for his last name.
Cogman,
you know what I'm talking about? Yeah, Cogman.
Yeah.
He commented
work with him.
He made a comment in fact that he just realized that he's been on 1Password since 2003, I believe. I think that's what he said in his tweet.
Wow.
So that's like, and just the fact that he's been on for like 20 years, which has been around for that long, or maybe it was 2013. I thought he said 2003, or maybe because 1Password has not been around for 20 years. It's only been around for 10 years, right?
I don't know how long it's been around.
I'd have to go look at the tweet there, but just got me to think about too, like early adopters and getting on something and then staying on it for a very long time and not realizing, and then think about 1Password too, because when that comes up for like renewal every year, I kind of think about like, do I really need this? Like, is this like an application that I rely on, that I need, or is it something that I could make myself? Like, do you ever kind of go through that process yourself, when you're paying for these services to make your life a little bit easier as a developer, and then you kind of wonder, how much time would it really take for me just to make a small version of this, not the full version, not the full multi-user, hosted solution that that 1Password is, but just for myself to have a way to have encrypted data.
Do I ever think about that?
I'm specifically thinking about 1Password because I have thought about this. Like, should I just do it? Because also each year I'm looking at the stuff that I'm relying on as a developer or as a tech professional, or whatever, and kind of think about all these services I pay for. The death by 1,000 subscriptions that we have to live with by either our monthly subscriptions or these yearly subscriptions that we have to kind of pay for. And I always kind of like, do I really need to pay for that? Do I really use it enough to make it worthwhile to actually pay for that service? Or is this something that maybe I should just take a week, a month, or whatever long it takes to make a small customized version for myself that then not have to rely on a third party service and pay a third party service for that service.
I have never thought about that in the context of a security software.
That's what I wanted to ask you about.
Like, so that never have I said, you know what I would like to do? I would like to take on more risk.
Well, if you think about let's just break down 1Password or these other these password applications or services. All they're doing really is taking your data, encrypting it. I've delved into far to see how they're encrypting it and seeing how secure it is, storing it someplace. So basically, like in a key value store, some type. I'm assuming under your account. And why isn't that something that we could do ourselves?
I mean, you can. There's probably open source.
So what would be your concerns if you did find a good kind of encryption method and process for storage? Is it the storage that you'd be worried about? Like if you're storing it off-site? Because if you did want to access it from multiple computers, you would have to wait to probably have it stored someplace on the cloud and have it synced up so you can access it from multiple places, and not just locally on one computer.
Yeah, I mean the storage should be fine too because you should be encrypting it with a public-private key.
Mm-hmm.
Right, so whatever's stored could only be unencrypted with the key, which should not be stored. Right, that's the thing. Like, and I believe that's how 1Password works. I use that for work. I don't actually use that myself.
Do you have like a company account that you kind of do share between people?
We each have logins, but it's like the password manager I use is Bitwarden. Which,
why would you use that over 1Password? Why do you like that?
I don't remember.
No,
I don't remember why. One thing is
because it's open source.
It's open source. Okay. I think you can host it yourself.
Okay.
So that's where I may be wrong.
Okay.
But I think if you wanted to, you could probably host that yourself. But they have plenty of ready built apps. There's a mobile app and all that kind of stuff. So yeah. I think you'd find, in terms of that particular thing, I think you'd find that yes, there's probably open source alternatives where you could just say spin up this instance, use that as even download the app and then use my own personal store as whatever my where my data is stored. So I'm just hosting that myself. But for what the cost is, it's not that.
Yeah, well, especially Bitwarden actually is cheaper than if I look at the personal plans. It's cheaper than 1Password. Yeah.
Yeah. So I like Bitwarden. I found it useful.
That's true, especially if the service is so cheap. Then you don't really need to ask yourself the question of should I really be paying for that if it's almost free?
Right. So that's where I would go for those type of things. But I do kind of appreciate your question.
There's something else that you've gone through that thought process before, and said instead of paying for this, I want to just make this myself.
That's always the problem from being a developer, right? Because you can look at something, you can say, I know how this is built. And in fact, I was doing a little bit more coding last week or this week than I've done recently. And it was a problem where it's like the solution to describe the solution is simple. We just said, oh, in this case, we need to reload the data from the database and try again. Just a simple retry. That is the solution. But then to actually do that and to make the fact that, well, this is persisting something to the database, and we do that in a bunch of different places. So we have to do this. We have to put this retry logic someplace that's common, and putting the retry logic someplace that's common, and making sure it's testable. Then bring it it was more involved than just I can describe the solution. I understand how the solution works, but the implementation of the solution can be much more complex than perhaps it seems. When we say, "Oh, I figured it out," that's one way. That's one part of it. I know the process with which this will now be solved, but actually then writing the code to do that is its own problem. Its own, and that's where is it a problem that you're solving? Is it art in its own way? Yes, it is in some ways, because it's how you're going to do that. Versus how somebody else might do it a different way. Sometimes it's so clear that pretty much everybody would write the same code. And that brings me to a thought that I had, and I don't know if it was your topic, 1Password. Was that your topic?
I actually have a couple.
It's just like doing the bare minimum just to be able to accomplish what you want to do.
Mm-hmm.
And this kind of ties into what I'm saying. Like when we were becoming programmers, yes, we were bouncing things on the screen because that's what we could accomplish. Right now, there's so many more platforms and tools. We've got the no code movement. We've got the it's in the cloud, the serverless movement, right? Where you're writing code, but you're just gonna let somebody else run it. You're not even gonna consider about how it's just gonna run, like the Amazon Lambda functions. You have you have the serverless concept where it's like, oh, we're now just orchestrating things and basically just tying things together. Or sorry, not the no code concept. So we've got more tools at hand, and when we want to do something, it's like I can know what I want to accomplish. You want to store your passwords someplace, right? And I can see the pieces, but then sometimes it's like, well, it would take me a decent amount of time to write something to do this. And I may not want to write something to do this. So as a developer, that may be my go-to, I don't want to say tool, but like my method is, okay, this is what I do. I sit down, I design a solution, I write the code, I deploy it someplace. But we have a whole lot more tools at our disposal now to be able to accomplish that. And the reason why this is on my mind is, I've got a thing. Before my dad died a year and a half ago, the thing that we gave him for Christmas was a little free library, and I was going to put it out in our field down toward the bottom, and then gave it to him at Christmas. It just had a couple more things that needed to be done before we're going to put it out there, and then after he died, I didn't really get it done. And I wanted to, and I still want to. And now I've got it pretty much in a place where it can go out there. And the thing that's holding me back is the fact that one of the last things he did was he went to a little free library that he would give his books to, and he got a bunch of his books back. He just went in there and was like, "Oh, these are the ones that I dropped off before Christmas. I'm gonna grab them because I'm gonna put them in my little free library." So I've got those books that he went out.
Now, when
and
you
got.
say, well, back up, define the free library.
Oh, okay. I guess yeah. Now, little free library is a movement. You may find them like throughout your town, right? And there's actually a couple in Hamburg and.
I know what a library is. I have checked books out before. I used to have a library. I used to have a library card.
What?
Don't have one anymore.
It was your card.
I had a personal library card. I remember that. It was good times hanging out in the library as a kid.
So a little free library, those things that you may see in front of a business or on the side of the road, and it's just like this house structure or any really structure with a door. You open it up and there's books inside, and it's a free library. You can just go grab a book. You can leave a book. That's what it says. It's the little thing.
At my gym, they have like a bookshelf. So as you walk out, there's like a bookshelf there, and there's like a free set of books, and that little sign there says, "Feel free to take, but then return or bring your own books." Yeah,
right. And that's the whole idea of the little free library. You can go there, grab a book. You can return it to that little free library, but my understanding and experience with that movement is far more like, if you do return it, you're probably going to return it to a different little free library. It's not like that library is going to have all the same, but that's going to have maybe that type of book, right? You go outside of some venue that caters to kids, you're probably going to find a lot of kids' books, right? Or maybe a farmer's market. Well, what do you think you're going to find at a farmer's market? Probably the type of titles that you would expect from people that go to farmers markets. You may find some things about alternative health, maybe homesteading, and then probably not, because everybody reads a novel, that's kind of cuts across the demographics, right? And that's the type of books you'll find in that, because it's around those people, right? So my dad would use those all the time. He'd love getting he would read a bunch of novels, and he'd go there and he'd grab these, what were pretty much, I think, a lot of times airport novels, right? And he'd read them, and he'd get different books from different authors that he would follow. And he'd get them from different little free libraries. He had a couple around his house that he would go to, and we were going to put one here. So when he visited here, he'd be able to go down to his little free library and stock it and all that kind of stuff. Yeah. So I have the books that he got to kind of seed that little free library. I have to put it in the ground and get it set up. It's actually behind me. But the thing that I want to do is I want to just put a sticker in there and be like, hey, this is a memory of my dad, and allow people to just say, oh yeah, I got that book, and watch it travel. If someone would say, scan the QR code or go to the link, and they could fill out a form and be like, yeah, I'm Bob, and I'm in wherever, and I got this book too, and this was the title. But at the same time, if they just scan the code, just be able to see it pass through, where whatever libraries it goes.
You should have like a book tracker.
Well, that's the thing. So it's like, oh, now but I want to accomplish it. I just want to get it done because I don't have time to write a book tracker. So then in my mind, like the thing that is of late going through my mind is, yes, I could build a simple book tracker with a form that says you go to my site, you submit it, but I don't actually have a site anymore. I've not done programming for myself in my own personal website for years. If you go to my domain, it redirects to my Twitter profile, right? And I don't want to go through
barely use Twitter then.
Yeah. I don't want to like have to deploy something to a server someplace. So that's why I'm thinking, it's like, well, what do I do? Can I deploy a static page that maybe redirects to a Google form that asks them to put in the ID and that to collect the data that way? And if I have a static page, can I use something like some type of metric? I'm thinking more like, you're familiar with Keen.io, right?
No.
It's kind of like an event stream type thing for the purposes of building aggregate data and things like that. But it definitely has a client side SDK. So maybe I can run some real simple JavaScript that says you go to this page, we extract the ID from the URL because you would have put it in the URL. We send it out to Keen. We also send whatever the browser tells us about location, IP address, whatever. So we can maybe get an idea that, oh, somebody who opened that book saw that link, went to that specific link that identifies the book, was in Florida or was in Wyoming. Oh, cool, it's made it there. And maybe then they actually get to the form and they put in their name and sign the guest book, so we have a real person that says, hey, I saw this book and this is where it ended up, and now I'm going to put it in this other little free library. But even if they don't, I can at least kind of see where it goes based on the web traffic without me having to build a thing that does that. But that's the trade-off, is like, I know how to build it. I could describe to you how to build it. Do I have the time to build and test and support and put it online and make sure it works? Probably not. So what can I cobble together out of all these cool tools that we have very readily accessible to accomplish the bare minimum of what I want to get done? And then if that works and is successful, maybe then I say, now it's worth some more investment to polish this a little bit. But I at least want to get that bare. So how do that's the MVP, right? Like, how do I build the MVP of just a little thing that I want to be able to do?
You could probably, what I would just do to make it easy from an end user standpoint, if I was going to be doing this, I would have like a QR code. I think that's what you're describing, right? So the user could just take out the camera, scan the QR code, because if you see a QR code, you want to see where it's going to go, right? That's a safe thing to do, right?
Yes, you always scan QR codes, and every USB you see on the ground, you shove it in your computer almost immediately.
So let's say somebody wants to do it, or maybe you'll put a little nice note below the QR code, say, "Don't worry, this is safe. I just want to
right.
keep."
Well, I figured there'd be something on the label that's like, here's the story. Follow this link or scan this QR code for more info. But anyway.
So what I would do is just have it go to a page and have like that page just have a nice little message, and the whole purpose of that page. Yeah, would you ask for the user to put in some information like their name or where their location is? I don't know. Maybe some way you could just get. I don't know. I'm not sure how much information you want to ask to collect it, but then just get the information you're going to get to. At least that book was scanned in the QR code. Send that to like a form, like a Google spreadsheet. Right. That's actually pretty easy to do. That's actually, I've done that before for a client where they like, without having to, they just want an interface they could access, like without having to build them a whole back end, like like an interface to see. They just want to have to know like this PDF that's on their website. They want to know just like how many times it's been downloaded. And also they want people to put in just a simple username password, just so they could just verify that number one, it was a valid person. And also they could probably check that username password back to a person. And they just wanted to have that stored. So I just used a Google spreadsheet, just took the data for that, plopped it in the Google spreadsheet, and then they could just log in the Google spreadsheet and check that whenever they want to. And I did have to build like a whole back end for it.
Right, and that's what. I think this ties into like what your question, Dave. Ever think of just taking these services and building them yourself? Yeah, there's probably services that could do what I want to do, but they're not what I want to do. Do I want to build this whole thing myself? No, I don't want to build this thing myself. I want to duct tape enough of it together so it works, right, and accomplishes what I want. I know how to build it. I could tell you how to build it. I don't want to spend the time building it because I'm not interested in creating a little free library book tracking system. Right?
Sounds pretty cool. I kind of like the idea.
Maybe it's a great idea, but that's not what I want to build. I just want to be able to say, oh, look, the books that my dad seeded this thing with have gone in these different places, and that's kind of just a cool thing to know that people are still passing around us. And then every once in a while, like years to come, oh, somebody else scanned it, so that somebody's still reading that book. So it's still it's still passing along, and they know it came from my dad, because they followed the link.
But Tim, you know what I would recommend you do? Because
no.
you maybe not to spend too much time with this. I think Google Code. I'm sorry, not Google Code. That's something completely different. I'm thinking about like Google Code. I was thinking about that. No, GitHub Copilot could write this for you.
You just have
to write it. Describe a comment, and it's going to write it for you.
Tap. I
did want to talk about it. That's the other thing. Remember back before school started, I talked about I was skeptical about this whole GitHub Copilot. I think I talked about this at the beginning of summer before we took our summer break.
Yeah.
And I was looking into it. It was first released, and they said they're going to start charging $10 a month for this. I'm like, is this really worth it? Is this service actually going to work? I'm using it now, specifically in my object-oriented programming class, because I switched to, I love using Replit for most of my classes because it's a great interactive experience with my students. But now in my object program, we're getting more to showing it how to use it in Visual Studio. And what I didn't realize of how, like, when I'm actually doing code demonstrations,
you're doing Visual Studio for Python?
Visual Studio Code, yeah.
Oh, VS Code. Okay, sorry.
VS Code, yeah. So I didn't realize this, but because usually I prep my demos beforehand, and then I'll have my notes to the side, like a kind of a version of my code that I want to show on my second monitor, so I can kind of peek at and just kind of make sure I'm keeping up to date with what I want to do, so I'm not too chaotic when I'm coding, which that can happen. I'm trying to describe what I'm doing, but I didn't realize that GitHub Copilot, it'll know what you typed before, and then the auto completes are super nice.
So you're just auto completing your own code.
I'm just hitting tab. It's like I don't have to type as much code. I just hit tab because it recognizes where I'm in the program. It knows I've already written this code before, and it just automatically just fills in that line for me. And then it's like super fast, because now I can get through a lot of code that I don't have to usually would have to type by hand. And that's always a struggle. You're trying to talk and teach and type code by hand. And it's like, my eyes are like so wide open. And then, and also just the fact too, it's so great, like how it'll analyze the code around the area you're working on, and the suggestions that it's making. Especially I'm not using it for a comment suggestions. Like I'm not typing comments and then saying, okay, do this for me, even though I have done that before. But there was this when I'm doing a pie game, like the while loop for the pie game, and there's this event loop. This is just a for loop by about 6 to 8 lines. It's like a standard loop, and then you put events you want to look for inside this loop. But once I do while true, and it knows I'm in the pie game program, it automatically suggests that block to me. I'm like, oh great, I don't have to type that myself. Hit tab, boom, I'm done. And I'm like, it's so amazing. It's so great. It's like, it really does open up a lot of doors. And you're talking about saving time now, because now I'm thinking about, wow, if I could actually, because there was, making a full application, you're talking about like when I would do a Firebase application, there's a lot of boilerplate code that I have to either copy paste from someplace or just write again. Now I'm thinking about okay, all this boilerplate code that I remember dragging my feet about writing or starting a project, because I'm like, oh, I'm going to have to do all this, the setup and everything like that. Copilot can just
tab it away. But so there's two things. One is your students are getting the world's best view of Copilot, because you are literally training it to type exactly what you want it to type. Because you are writing the code, and then it's told them, this looks really familiar.
And I haven't told them. That's true. Well, I told them ahead of time. It's like, okay, in order to get through all this code fast, I have this extensions plugin that does these snippets for me. So I'm I didn't really, because I'm not telling them exactly what I'm using either. I just say okay, I've already written this before, and so you're going to see these snippets pop up, in order for me to kind of quickly get through this. But it does simplify.
It seems like it's a great use case for GitHub Copilot. This to me seems tremendous, but it also says to me that once you write that for that standard for event loop, right, and to look for events, cool, and then you do it again. Oh, it's the same code, right? I'm just going to write the same code. So then, as you get into say something that's not a teaching, not your use case, but I'm in our code base, and it's like, oh, I'm going to do this thing again. And I start typing this oh, you mean this thing? And it's like, yeah, I mean those 20 lines of code. Just plop it in here because I need a method to check a thing, to do to do this, and now I'm just going to subtly change it. Just a little bit of the internal function. But to me, it feels like then Copilot is working against the do not repeat yourself principle, because we're making it really easy to repeat ourselves.
That's interesting.
Because a lot of times the developer pain that says, oh, I should extract this out into a generic method that can be called, a lot of times that comes from it being so tedious to type it. And you're telling me, oh, all the tedium's gone, GitHub Copilot just spit it out. But then what about maintenance? What about when you realize that seed method that you're copying everywhere wasn't great and you need to refactor it. Now you need to refactor it in 15 different places because
I do
Copilot
think
made it really easy to copy it.
And that'll be interesting too. If your source control is hosted on GitHub, and if it's doing analysis, if you give it permission to do analysis of your repo, would it actually start suggesting to you refactoring options?
Oh, refactoring as you touch the code again.
Yeah. So it actually says, the way you're writing this method is also written in this other file here.
Right.
Do you want to refactor it and put in this, make a whole new class out or whatever you're going to do? If it starts making it just like that and do like automated AI refactoring, that could also be kind of cool.
But what it makes me think about is something we talked about, I think 2-3 weeks ago now? No, probably 2 weeks ago. The abstract syntax tree. And the idea that even if you did do that, you may be able to automatically have a computer refactor for you. Maybe we'll talk about that a little bit more next week.
Yeah, GitHub Copilot. I'm happy. That's what's one service I am happy to pay $10 a month for.
Oh boy, should we end the stream? I don't think
sure.